little bit.
Yeah.
Maybe it goes through. So you probably are hearing me. Okay, delay, but it's there. So you probably are hearing me. Okay, delay.
Delay is expected, but that's perfect.
Yeah.
Turn camera off, sound off. Now I need to make sure that he joins. He is, yeah, but that's good. We have it, right?
Mm-hmm.
Now I need to try the recording at the same time.
Mm-hmm.
So, no, actually, I'm not gonna record, right?
It will be him.
Yeah. What's gonna happen now anyways, since I know I'm connected to mine, is that eventually YouTube automatically publishes the call in my YouTube channel. I can then unlist it afterwards, but then I can at least take that raw footage. I don't know what definition it will be, but I can at least download that before I delete it. If we delete it, it could be nice to just have it there. Can anyways upload it to the vienna.go user channel. But that's like an extra.
You can still test if you can because you are streaming also, so you can test if the OBS will record.
Yeah, but I think I don't want to like. I'd rather just now us have the stream set up, then also record and have it crash because the whole live stream crashes, and then because now if we get him nicely set up with the screen recording, connecting to the conference, then we get what we need.
Yeah,
we have one screen recording on his, and then I know that it will record. YouTube will automatically record it.
Right.
So I don't know if the quality is the only thing. So then, and it will be delayed, but you can anyways then sync it. Yeah, I think we got this.
So we just need to try. Let's see.
Yeah, best. Yeah. We should already have been here.
And then what do you say we turn this 90 degrees?
Oh yeah. Or we could just maybe move it a little bit.
Wait.
Okay. Thanks.
Yes.
Because then we can, so I'm not really interfering, I can have this one here. And then they will see me, but we're anyways not going to present that, we're only going to present his screen for most of it. Then before I talk, I go here and I switch, but then I go in front here anyways. And if I see myself there, now they see me. Yeah. Yeah. I can move this a little.
So again, you will be talking first.
Yeah.
But okay.
Yeah.
And then he will talk where exactly?
I was imagining maybe in the corner there, so where you're aiming at. Yeah. And now I can just do like this, and then it switches. And I can do, now I want the Robert to be talking. So it's perfect. So that's kind of like a control center, and I can also do it over there. Maybe because, can we just switch now because then we can see how it looks. Now the room looks nice. I want it over there. We can't really improve on that. Maybe I should just put the cable is not long enough. Yeah, but that's fine. I think if we can just move. Yeah, we just move everything a little bit back so I have more room to stand there, and then I think we're good to go.
We move these, and I think it will be great.
Yeah.
We'll have a table there.
Or should we keep it like this, you mean?
No, we just move these two, right? And you will stand where they are.
Yeah, I was thinking we just move all the four so it's like.
Okay, there?
Yeah.
Then you stand there.
Yeah.
Okay.
Then at the end we can just move the two tables over there. So play like, what is it? It's a game. I feel like we're playing a game, like a. Maybe make it easier for ourselves. Make it so that it's like when we end up, we have that enough space for these here. Yeah, perfect. Everything we are saying is on live stream. You can just mute.
Just waiting for you guys. We need listeners, we need viewers, we need people here. So come on, come on.
Perfect. Perfect. It's starting to feel professional, man. start working.
Perfect. Okay.
So let's just test now. If it works, we'll start shortly. This is all. Let's try and figure out if it goes or not. Oh, cool. Okay. Good.
Works.
Yeah.
It's good.
So I see we have some people from the meetup. We have Christian Haas, we have Rodolfo with us. If you haven't got the link and you want to join the Hangouts with us, Rodolfo, let me know. Otherwise, you should have gotten in the email. It's cool if you just keep the chat room active. That's also good. I need to look at the camera. We have King Julian here. Hello, hello. We have JJ Kanej, who I think I know from my gaming stream on Twitch with Fortnite. So this is new to you. This is a meetup about Golang, the programming language. Good. Learn Golang on Fortnite. Perfect. Great. I don't think we'll be too many. Apparently, we're 7 total people here today. This is so we can try and have something. I'll do the proper intro in a couple of minutes. Until then, shout in the chat if there is anything. And I hope it'll be a good event. We'll stay in the chat. We'll make it one. Good. So. Good. Yeah, you want to do that? So I didn't do that. That works very well. Cool. Nice background.
Would you say something?
Hello.
Do you want a drink or?
No, it's fine.
Yeah.
For now. Just can be there somewhere.
Just good. Okay.
Would you say something?
Hello, hello. Hello.
Okay. Could you maybe come here for a second?
Yeah, sure.
Because something is
Hello.
Hello, hello, hello. Could you turn around there?
We're getting ready. We just have to mic up and make sure everything works. Give us a minute more. We'll be there.
Hello, does it work?
Okay. Just give me some time to start. Afterwards, we'll make it so that in the beginning, you can stand here with us, Alexander, and just say hi so people get to see you.
So
Afterwards, we'll do questions from the chat. If someone have anything, then you can answer them there if you want.
Okay.
But just you can stay for now.
Okay.
Okay. Okay. Hope you're still with us. I lost the chat, so please let me know in the chat if you hear us or not, if everything is fine. And I'll have a look. Thanks, everyone. It's really strange today. Some of you have already been to our meetup before in person. The room is normally maybe not full, but we've been at the most, I think, 25, 30 for a really big Golang meetup. Sometimes we're just 10. But it's nice to have a community that we can be together about. Good. I think we're good. I don't see some. Oh, I hear sound good in the chat, so I know you're hearing us. There's not so much today in terms of. Normally we have some slides, maybe some community news. That's maybe for the next live stream if we have more to figure out, because now it's enough to for me to present to you guys, and then we'll share the screen of the speaker afterwards, so you can get some good content. We'll also record this like usual. We're trying to have the normal videos that get published to Pusher sessions. So we have a film crew here today. Thanks to Pusher for sponsoring us as always. Thanks for EPCONT for making this possible in their location. EPCONT is hiring as always. No pure Golang positions, but we have some operations where people get to play around with Golang. We are mainly a Java company. But feel free to have a look at EPCONT, epcont.com, and look at the jobs there. There's also mentioned in the program of the meetup. Just for confusion, I'm streaming to my personal YouTube channel today. I tried to set up the vienna.go YouTube channel, but there was problems connecting it with the streaming software we're using, so we just went with plan B. But we'll try and put the recordings in a proper Golang, Vienna Golang user space. So I know we have some people from, I've done some game streaming before, so I saw that JJ Kaneje is joining. Maybe confused, this is for the Golang programming language. Yeah, and to address the elephant in the room, as everyone knows by now, there is the coronavirus, which is why we tried to do our best in providing some content, even though we're not here live with you today. It's also a trial run. I run 3 other meetups, so it's also cool to see if we can, as a meetup community in Vienna, provide meetups like this. So we'll see if this works well, if we're going to do this more or not. I'd love to hear your feedback in the chat or afterwards in the meetup comments. I think that's it. Alexander, feel free to come on camera.
Hello everyone, good evening.
This guy will be talking to you and presenting a as part of his talk, I'm sure, an intro mentioning himself. If not, you can say a few words now.
Yeah, like I work as a senior software engineer at Radar. This is like Viennese company in travel industry. I'll also give a bit intro of this company too. We do Golang. We do actually a lot of Golangs recently, and yeah, we do also PHP and other languages. So yeah, we have microservices. That's why this talk kind of was from our initial like conversation internally.
Cool. In terms of, yeah, very good. I think also if you're on YouTube, in the YouTube channel, the recording of this live stream thing will be made publicly available automatically. So feel free to share that, or we can share that with others that didn't make it in this time frame. Much more to say other than hope to see you again in April. None of us really knows what these Corona times are going to bring. Wish you all safety and good health, and very happy that we can do this live stream today and that it seems to be working out. After the talk, it's going to be tentatively, we're thinking around half an hour for the talk. After the talk, we're open to questions. We'll try our best to facilitate that. Post your questions during the talk or afterwards in the chat. And if I fail to see them in the chat afterwards, post them again, because I checked on my phone now. It seems like I lose some of the old chats if I go back in and back in. So keep your questions until the end of the talk. I don't think it'll be so easy for us to keep some socializing, but we already have people some texting in the chat. So let's have that be our socializing today. I cannot promise that we keep the live stream open so much more after the questions. But maybe we could facilitate at least like 15 minutes for people to post their questions and maybe chat a little bit together before we say goodbye. So, without further ado, I think we're ready, everyone. You have the screen recording going.
Yep.
You are in the room, so when I have given you the right to present, we'll start the talk. Thanks, everyone.
So, good evening, everyone, again. So my talk today is about distributed tracing. Well, actually, this topic is because in Radar, like a year ago, we started to write services in Golang, and we started to write microservices. To share some knowledge internally, we started a Golang guild that where like everyone can present their topics, and like this was actually a recent topic of this guild. So what's Radar? This is the world's leading online marketplace of multi-day touring. So you can, if you go for a few days to some country, you have more than 40,000 tours and 3 million monthly visits. So from a technical perspective, we have like a year ago we used to have 20 services. And by during the year we grew that number of services to 60, like more than even 60 of different services. And we have external services that are like customer specific. We have also internal, for example, rates calculations or different events processing. And that's it. Like mostly recently we are doing everything only in Golang. So like what's the actually problem here with distributed tracing? Imagine that like you received an alert that your application performance is actually degraded, and now you are trying to figure out like what happened. And imagine that you are in the microservice world, so you are not like it's not monolith, it's not one application, it's connected to different services, and you actually want to see what's happening. What's your first step? You will go to the logs, and yeah, logs can help you to understand what's the performance and like what's the current setup of your system, how it works, and what's actually happened. But if you have microservices, if your architecture is actually distributed, that's going to be a pain, because you need to like see logs from different services and combine them all together by, I don't know, some identificator that you can use, or IP address of some user. So actually traditional debugging doesn't scale because logs are distributed. So this is actually very challenging to monitor performance, and that was a pain for us because our main customer's driver is actually SEO. So the speed is actually very like it's a concern because Google actually monitors the speed if you want to be on the highest position. So what was our step? We implemented distributed tracing. Distributed tracing is actually a concept where your request, it goes from, is tracked as you traverse services. So on the point of ingress, like your load balancer or any other like first service, a gateway service, it assigns a unique identificator, and it sends this identificator from service to service. So then you can like combine everything together and see the trace. Often you have on every like service you have segments, or they often also call it spans, that kind of describe what this particular service is doing right now. So yeah, while logs can be important checkpoints while servicing requests, a trace actually connects all these logs like checkpoints into a complete route. So you can see what it explains you how your request is traversing across the services. Yeah, usually the segment data of some service, it has the timestamp, it has DNS lookup time, TLS lookup time, so like everything that can be helpful to understand what's going in this particular system. So actually, our solution was to use X-ray, AWS X-ray, because mainly our all architecture in cloud, and we use AWS a lot. So we kind of rely on their provided services, and it's very nicely integrated in the whole like their world of services. So you can easily integrate it with I don't know Lambda's API gateway or your CloudWatch, so like logs, and you can see a service map. So this is a nice thing. It gives you a performance view of all the AWS services you have. So HTTP database calls, SQS, for example, queues if you use some. You can also, it provides you ability to see what's like where you have performance bottlenecks. Also it gives you insights on the errors and the fault failures, for example, 500 errors, 400 errors of your APIs. Also you can instrument your code with some annotations that will help you to actually filter your traces, and you find like exactly trace of some user or trace by some ID, for example, ID of some, let's say, blog post or something like that. It also has built-in analytics, so you can have like a trend. You can see what's the trend of your performance, how it's going, and how it will go. So like time peaks, you can analyze all this stuff. Yeah, so how does it work? It's very easy. It's just the AWS X-ray, and actually most of tools for distributed tracing, they are combined of two things. First is the daemon, and second is the API. So for Go application, to start to capture data, you just put X-ray SDK, and this SDK, you just instrument your code with this SDK, so you put different calls. And this SDK will just send data by UDP protocol, so 2000 port. It will send this whole data to the daemon. This is a special service which stays, for example, if you use Docker, it will stay on the sidecar container, or it will be, if you just on the usual server, it's just a daemon that runs in the background. So by that, you send some data, and this daemon just collects this data to the buffer, and every n seconds, it just sends everything to X-ray API or any other API. And then your traces are combined, and they appear on the list. So this is how the X-ray console looks like. You have traces here, like basic view, so ID of the trace, age. So for example, you can see recent traces or old traces, the HTTP method, which was like for this specific request, and response was what was the response code. Response time, for example, you can see if you want to see like what was the slowest part, and the URL, of course. And also you can also see that we have a view of boundaries of your services. So like you can see the service map, and by clicking to some services, you can see what's the performance, what the value rates, and like you can find what is failing in all your architecture from just one simple look. Yeah. So now let's go to the first initial step. We just need to set up infrastructure. So how would you do it if you have AWS? And mostly, yeah, I would say that mostly like nowadays people use AWS for their services because it's easy to set up and easy to manage, like with a nice cost. So first, it's easy to host a service. So for example, if your application is just like you have a service, you don't have any Docker or whatever, like you just have a service. That would be easy because you just you do a curl request, you install X-ray daemon. After that, it automatically starts, and you can configure. It's optionally because it has default configuration. You can also configure, for example, by resetting setting other port or some log specific configurations, for example, log level. Also, you need to give rights to the server to actually push data to X-ray API. And you need to initialize the main segment of your app. Yeah, we will talk about this in a few minutes. This is first. For example, if you have the Dockerized application and you, for example, for some reason you use ECS, so this is Elastic Container Services, you just put a sidecar. Sidecar is just a container that is running with your container. So there is a special setup, which is on the screen. You can see on the slide. You can see the setup of this sidecar container in container definitions. You just put this X-ray daemon there from Amazon's Docker image, and then you can configure optionally. But for that, you need to create your own Docker file. You give IAM rights, so the same. So just the difference is only in Docker image itself. Then we have the easiest part. It's AWS Lambda. So like right now, many companies, they leverage serverless architecture because it's easy to set up. You just put your file, you just create a function, you upload this function, and that's it. So you have runtime. Go is supported in GCP. It's also supported in AWS. So you just put a file, a binary file to the AWS Lambda console, or you upload it somewhere, and then it works. You don't need to set up server. You don't need to do anything, and it just works. And actually, tracing for such services would be the easiest part because you just need to enable the flag, enable active tracing. And that's it. That's the only thing you need to actually start. It's the X-ray daemon is built in already. So the only note here, which we have from experience, is actually if you use SDK, you need to use version V100 RC1 and higher because it's only a version that has Lambda support. All other versions lower, they don't have. So you just need this. You can also enable X-ray tracing if you use API gateway. API gateway is kind of if you want your Lambda to be accessible and be like an API. So you just put a flag and that's it. It works. So now we're gonna see how to instrument application. So the main part of this. So first, this is configuration. First, we need to import all the needed libraries and configure them. So for that, we need to first configure the daemon address. By default, it's just localhost 2000 port. We also need to configure the sampling strategy. So sampling strategy is like if you want all your requests to be traced, you need to create your own JSON file with the configuration. Also, there is ability to set up this remotely, so in an X-Ray console, and it will pull the configuration from X-Ray console in AWS, and there will be like your custom configuration. By default, the first request every second will be sampled, and then only 5% of all other requests. So like first request every second will be sampled. You can also set up here your custom logger, because X-Ray has logging built in. You can see like how it sends data to the daemon and how it works. You can also put some custom logger, but yeah, usually it's enough to just put daemon address and sampling strategy if you need. Also, the important part is you need to enable plugins. There are 3 plugins for ECS, so if you use Dockerized, EC2 if you use server, and Elastic Beanstalk. So you have just 3 plugins, and you can, if you use ECS, you just need to import without like a named import. Then the main segment. Actually, main segment is the critical part, because main segment is like thing that wraps all your it's like your service trace wrapper. So like you need here to put the main information about the request itself. So for example, if your application is Lambda, is serverless, then you don't need to stop it. It will be automatically set up and will be provided by context. So we know that in Golang, there is a context package, and context can be a timeout, can be with cancel function, and can be with value. So you can send some value through the context package, and it actually does this thing. It wraps the whole handler of Lambda function to the with the X-Ray trace ID, and then you just use it. So you don't need to write a main segment. But for example, if you use other type of application, for example, HTTP server, HTTP API, you will need to do it. So every time you get the request, you need to wrap this request with the main segment, because every trace must have this segment. In X-Ray, it's actually really easy, because X-Ray has X-Ray SDK for Go. It has a special handler for HTTP. So you just wrap your HTTP handler with X-Ray handler, and you put the name. It will automatically add all the request information, for example, like a client IP address. There is also other information like what's the method, what's the response code. So it will just act as a wrapper of your handler, and that's it. It will also catch errors and stuff that's going on. If you run some other type of application, let's say CLI, so like you have command line interface and you want to see what's going on there, there's also, you can just create a X-ray like begin segment. That's it. I will show you it also in the demo. Actually, in our case, we use a Gin framework. We don't use the net HTTP. We use Gin framework, and in Gin framework, you can either use there is an own package that's like not popular, but you can use it, that package. We just forked that package and created our own. So we wrap with middlewares, we use middlewares, and we wrap all the queries, and we just wait for the query to be done, and then we read, okay, so was there some issue during the execution? Do we need to, if there was like a panic, we need to catch that panic with recover, and then write something to tracing, so we will know what's happened during this request. So now the downstream calls. So for example, if your application is connected to different services, you need to also send this request. So your service map will look like it will have connections to different requests to different services. In X-Ray SDK for Go, it's supported out in the box. So it's very easy. You just wrap different calls with different methods. I will show you that, and it automatically creates a proper header for the request, and then it just works, and service map can see it. If you don't have X-Ray SDK and you use just a plain, or you want to send some request there, you need to have X Amazon trace ID header, and the value will be root equals the main trace ID, which you just generate. There is parent. Parent is actually a current segment ID. So you have segments and subsegments of your application, and parent it will be segment ID. So where your application, where your like downstream call is started during, like in what actually spun. Is it started like from the root, or is started during some like special custom segment, like I don't know, fetching information for something. Also, you can set up sampled 0 or 1. It's a flag. So your downstream calls can understand that this query is already sampled, and I don't need to decide should I sample it or not. Because if your main point of ingress started to sample, then like all your downstream applications must sample, because then you will have the whole picture of this request, this particular request. Also, if you use Elastic Load Balancer, it automatically generates a new trace ID. You don't need to care about this. If you send it, will application load balancer will just do it. So now we are going to, like, when we have a main segment, when we know how to do downstream calls, now we need to instrument our application parts. So for example, to understand then that, because if you just have main segment, you will say, okay, so this API in total took, I don't know, 300 milliseconds, but you don't know what happened in this particular API, what exactly was like function calls, what was processing, what parts took what time. For that, you need to have subsegments. So they extend trace segments with details that you can actually specify. So there are actually two ways to wrap your code. First way is also on this slide. You can see the first way will be you just begin subsegment and close it. That will be also on the demo. And then another will be a wrapper. So you just, and this will be a function with that returns error. And that's it. You just use X-ray methods. You can add annotation, add metadata. So actually, about annotation and metadata, annotations is a key value thing that you can use then for filtering. So if you want to, if your information is some like filter-specific information, like in this case it's user ID, this is very useful to be filtered then. You add annotation. If your information is just, I don't know, JSON response of your, I don't know, like some API or some just some structure, map, or whatever, you will use metadata, because but this you cannot filter, you can just see it when you click on the trace on this segment in the console. So yeah, so it will send all the data in the, with the execution time. So every time you actually start and when you stop the segment, it will send the execution time of this particular segment, and you can see what for example was the slowest part in whole your application. Yeah, now the HTTP client. Usually when we already described that like we want to, for example, call some external API, and we use for that, usually everyone uses HTTP client, not just default HTTP client, just by adding timeout, adding transport, or whatever for microservices. But in this case, this is also very easy, because we just put X-ray client wrapper from X-ray, and it will create automatically a special, like it will wrap round tripper. So the transport part, it will wrap with special X-ray round tripper. And the main part here is actually to not also forget that you need to add context to your request. Usually people don't add context, so they just do requests. But it's very important to add this context. So there are two ways. Either you go with XNet context context HTTP package, which can wrap your client with the context, or like the easiest part without having some external packages. You just have request equals request with context. That's it, and that works. And we have request wrapped with context, which means actually that, for example, if your application, let's say you have an API, and your API is, for example, slow, and we should kill it by timeout, your HTTP call will be automatically stopped because you have context, and this context has some timeout or cancel function, and it will automatically just stop the whole processing of HTTP client. So it's not only useful for to wrap request with context for X-ray, but it's also useful for the application to handle gracefully some failures or when person just sees that your application doesn't perform and stops the request. Yeah, so this, and also you can wrap SQL queries. That's very easy. Instead of SQL open, you just use X-ray SQL. The same thing, but it just wraps the SQL calls. It puts the nicest part here is that it actually then in X-ray console you can see the whole query. And for example, you see that this query performs, like SQL call performs really badly. You can just copy the whole SQL and put it to some debugger, put explain and see what's happening exactly there. And that's, I think, pretty useful. The final part is when you use other AWS services. For example, you have a DynamoDB, your architecture is serverless, and you use DynamoDB. Or you use, I don't know, Kinesis. Amazon S3 is very usual thing. For example, when you put some files to S3 or you get some files from S3, you need to wrap and see what's the timing, is it failing, if all the files are there. So SNS, SQS, everything. And it's very easy because you just use the native AWS SDK functions. So you use DynamoDB from AWS SDK. But with that, you just wrap X-ray AWS Dynamo client. And then automatically X-ray will understand that you have downstream code to some client. So now I will show you actually how it works. Yeah, so let's say we have very simple app. It's very simple. So let's say we have main. That's show. Okay. Yeah. So we have configuration. First, we actually will increase the size. So it will be readable. Yeah. So first, the point is that we configure our X-ray. Then we create some context. In this case, because it's not actually request, it will be context background. So it's like default context of the application. Then we create a main segment. So like, what's your app segment? And from here, our context will be wrapped. So it will have information about context. So it will be context with value. Then you have segment. Segment you can use for like different purposes. In this case, I have service, and I can set up version, my custom version of this service to understand what was the, for example, deployment version. Let's say we have segment ID. We can, in this, I would say like get. We can use get SQL and put some data about SQL if you want. You can get HTTP, and then you have get request. You can set up URL, user agent, client IP, Meetup, trace, export, so like some default stuff that will make your application look like in the X-ray. It will understand that this is HTTP call, this is SQL call, so it will differ them, and your UI will look like even better. For example, in this case, we have calls annotation, so like type, let's say POC, and yeah, then we can, like I said, we can put URL, and we close this segment. You can close it with error, by the way. So here you will just use like errors. You can close it with error, but in this case we will not. There is also another way to put errors. So you do segment and then error, or you can also use add error. And here we just put some errors. So just create some error. And there is also add error, and there is also add fail. Followed, yeah. So you can say that it failed. So failure means that your application completely stopped up to this point to work. So now we have two actually calls. One is do something and one HTTP call. Let's go to the do something first. Do something will just create a subsegment. So it's like And from your segment, we create a child, and then we create and say, yeah, do something. We add metadata, which can be anything. It's just a type interface. You can add whatever you want. In this case, I will just use typical, like for JSON decoding and coding structure, with sleep 5 seconds, and then we create it. We just add another metadata, and we close the segment. That's it. For the HTTP call, first we will create a new client. The client will be a usual HTTP client, 30 milliseconds timeout, and then we wrap this X-ray client with x-ray.client and the HTTP client. That's it. So now we create a subsegment, HTTP call, and we create a request to, let's say, to Radar. This request will be wrapped with the context. This is a very important part to do it. Then when we have error, for example, in this case, we have, if our error exists, we need first to log that it's pattern error, and second, we can add this error to the subsegment. So subsegment will have this error inside, and it will show it. The other part is response, the same, so we do the request, and we do the same error handling that we did before. And now, the also thing that we have response decoded. It will be just HTML code because it's super long. I will just find first occurrence, like index of substring to Radar in the response. And that's pretty much it. This is the code that we have. And now let's go to the server that we have. So, okay, so I created this very simple server. It's just the EC2 machine with just Go, and that it doesn't have anything. And we'll install X-ray on this machine.
Can you make it a little bit bigger? Is it possible?
Yeah, I think with
Control plus maybe?
Control plus, you see. Okay,
So, or Command plus?
nope,
Okay, oh, that's fine.
work, but I can actually. Here they have profiles. We need to.
Yeah.
Okay, so here and yeah, okay, text.
Wonderful. Well,
This is here, but yeah, cool. So yeah, we can now use the script that they provided. By this script, we install. Okay. Yeah, we have this, and now I think we need to install the server. Yep. Okay, so now we check if X-ray is actually working. Oops. Yeah, so X-ray daemon is here, it works. And we can also read logs from X-ray daemon. Let's see, and yeah, see we have initialized X-ray daemon, buffer memory limit 9 megabytes, region is US1, so like typical stuff, X-ray points and yeah, other information. So now we can actually run our application. Our application already, which I showed you, we can modify. So this do something, yeah, so the same application that we have. Okay, so just to make sure that we have everything to run it. Yep. And now, it's done. Then from here we can actually go to X-ray console and check if we have something in the console itself. Yeah, we have a few first trace. It doesn't have meter, it doesn't have response for sure because it's not the HTTP call. It wasn't and it has one annotation. You can see this was one OK, no errors, no faults, nothing. And we open this trace. So first we should see a method response duration age ID, so something basic. Then you can see the source map of this particular request. And in this case, we have my test app, it's like our main segment. And we have an external call to the to radar.com. So yeah, now we can also put icons. And, there are different things. Raw data, you can see if you want to find how it sent data and how it collected in the database. The use, it's also here. But for us, it's interesting how it actually looks here. So first we did do something, and if you remember, we waited 5 seconds. Now you can see, we waited for 5 seconds. So here is the resource, so parent ID, subsegment ID, start time, end time, duration. So you can see everything of your about the application. You can also see metadata. Because we added metadata, we added data after and data before. So before was like before waiting and then after waiting. So it combines them all together, and you can see in like any different scenarios, it will just encode it to be a JSON string. You can also add exceptions by like the function add error will do this. Then HTTP call, because this was a subsegment. It took 172 milliseconds. You can see on this graph how it actually most of time was taken by the sleeping, like 5 seconds. And here we see that it took 172 milliseconds. And then this part is actually provided by AWS X-Ray. So when you wrap in your HTTP client with this function, it actually does like all this stuff. And here is, for us, it's very useful because, for example, we know what the response was, like 200, and we have request needed was get, and then let's say, I don't know if we have some sources of annotation, so yeah, nothing here because we don't have errors or stuff like that. But we can also see that 13 milliseconds it took to actually do DNS resolution. And yeah, for this case, we have metadata. So what was the addresses of, in this case, we don't see, but like internally, we actually see that what was the address of, that's also dial. You can see that network was used TCP, of course. Also, you have TLS. So what was the TLS resolution? So cipher type. So all the useful information for debugging HTTP requests. You can see requests and how much it took to actually encode the request. And so it's 0 milliseconds. But to actually decode the request for reading it to buffer, it took like most of time here. Because this is for connection and this is for getting and decoding the response. So yeah, we have this, and yeah, actually in base segment, HTTP call, we have metadata, and response is first occurrence, index of first occurrence of the radar string, and we have that, 73. So this is basically it, and yeah, we can also see the general servers map of X-ray, actually not really fast, yeah, but in this case here. So client, my test app, it called my test app, it took, so we have only 0 to connections per minute, and it also connects to radar.com. There is also filtering, so you can wrap like service and say my test app. It will filter out, it will filter out everything only for your special service, and I'll find all the traces that needed to be on this service. And there is also analytics that I already showed you. So you have what's the latency, what's the different percentiles of the latency, and stuff like that. What's the popular user agents, methods, what the response time, and like root causes of slow responses and stuff like that. Yeah, so that's pretty much it. And yeah, also, like I wanted to say that X-ray and like distributed tracing overall helped us a lot in the company because we created a few services on top of like our search infrastructure, and they all they were very tied together. For example, there are services for machine learning, there are services for retrieving the search data, and we had performance issues in some of services. And before we had this distributed tracing, we didn't have enough like observability, how we could improve and what's the exactly bottleneck, where the service performs worst. For example, we saw that one of our services was performing really bad because of JSON decoding. And then by having X-ray, we instrumented all the code with these subsegments. So like the part of decoding starts, the part of encoding, the part of request starts, And then we saw, okay, so the part of decoding of JSON was the slowest part. And then we did it with the data. So for example, what exactly here is slow? And we just put timings. Yeah, so like even if you add many different subsegments, it doesn't harm performance if you add, because you just send everything to UDP, so you don't need like to have handshakes, and you don't have that latency of, or you don't write to file, so you don't have that latency too. Yeah, so, and that's actually, I don't know, it's not really visible, yeah, but we have also some traces. So usually it's like very long trace of some like calls to Redis, calls to MySQL, calls to different services, and you just read that call and you see, okay, so this part was like the slowest part. Here's the usually it's very helpful, for example, for SQL queries in our case, or microservices. Yeah, so thank you, and I'm looking forward for the questions if you have any.
Yeah. Thanks. Cool. Woohoo. Well done. Oh, yeah.
Yeah.
Come.
Okay.
So let's have a look. Wait a second before you post something. Oh, question from Christian Haas. Oh, and then I make it go away. You mentioned a small. Oh shit.
Can you copy and paste your question again, Christian? We only got the first part of it before it refreshed here.
And let me stay in the corner.
So feel free, anyone else, to post a question. I know there's some delay here between when we speak and when you hear it, but feel free to post your questions. It was Rodolfo. I think the question was originally from Christian. You mentioned a small Go community in your company. Assuming your employees grew with their Go knowledge, what happens with complete newcomers to Go? How can they catch up?
Yeah, that's a nice question actually, because currently we still have newcomers into Go, because some people, they still like they do some usual PHP development, or they support our monolith, and then suddenly, for example, we just say, okay, so now we have some flow that should be automated, and for that it would be useful to use like serverless architecture or create a new API. Usually they will go with the Golang, of course, and for that. I actually recently also had onboarding with one guy who wanted to participate in my project, and like because we created like a team for like finishing everything there. So I would start like what we usually have. For example, in this Golang guild, this community. Every month we gather and we have only 2 presentations. So every presentation is 15 minutes, then 15 minutes of questions. Usually the first presentation is very basic. So like, I don't know, a topic, what was my road to Go, like how I was learning Go, and what was my challenges in Go. So like very basic topics. And another one is very advanced. So like memory management in Go, how to compile, how to read like very low level Go programming. So people, different people with different experience, they share, like, for example, newcomers, they share more like basic stuff, and we also have some who has more experience, they do this. Yeah, the question was from my newcomer, that was question because he started from Udemy courses of Go, and he said that they suck. Like usually they are very boring, and basically people just give you introduction how to do calculator or something very basic in Go. And I suggested him a book. I think it's like the first book, actually, I don't remember. It's called, Go Programming, Go Programming Language or something like that. It's just like white book from creators of Go. I forgot, like there are many of creators, and I forgot what exactly. And we have that 3 copies of that book. And actually, after that, because it was Friday, and he's asked me what he should do because he doesn't understand the code of our application, how it works, because he came from PHP. I said it's very easy. You just take a book, you just see the code from like some application. You can go to GitHub and download some application. You see the code, and then you just take a book to understand what's the basic syntax of the language, like how to do testing in language, how to do for each, like very basic like stuff that everyone does every day. So how to do sorting, functions, structures, and then you just go to popular GitHub projects and you just read them and see, okay, so this is how they do, for example, package management, project layout, how to structure, how to call, what is init function, what is main function, how to do modules. That usually for Go it has very low learning curve. So with that, by just having some book to like as a source of, if you even like just read it very quickly, then you can understand very easily like existing code. I was actually learning everything, also Udemy, 3 courses, no result. But after checking GitHub, Docker, Kubernetes, Terraform, they all built in Go, and they have nice nice structure. And you can just say, okay, so Grafana, also like open source project in Go, and you can see how they structure, how they work, and by that, by just following that same principles, you will learn Go in a maximum.
Nice, nice. We already have 2 more questions. How do you do vulnerability dependency checking?
What?
I guess it is vulnerability checking of the dependencies.
Okay, so that interesting question, because like ideally you would use like in Go you can actually stick with some version of in Go modules you can stick with some particular version or particular commit, and that kind of gives you that vulnerability checking. But actually the best way will be to use Go proxy. But Go proxy for the packages, normally it was introduced only recently, like in Go 1.11 I think it wasn't there. I think 1.13 it was like close to be normal. Yeah, so we don't do it. Like you need to set up proxy, Go proxy, you need to put the server for proxying, and it will just download dependencies and it will keep them like in the safe place. But we don't do it.
Okay, cool. Do you miss something that X-Ray doesn't provide?
Yeah, partly I would say the UI in some way. CloudWatch is not the best like UI UX, so you need to get used to it. Plus PHP, lack of PHP support. It only supports Node.js, Python, Java, and Go. It doesn't support PHP at all. We have custom library that was forked from another library that is like pretty hacky. Yeah, so I would think that's if your company, like usually companies that use Go, they have PHP monolith and then they use Go as like for microservices. Usually you have some monolith in some language, then you have something else. In this case, yeah, we just use PHP. We don't have anything. That's like I think it's a huge drawback if you use X-Ray.
Okay, cool. But I think that's it. Thanks to Christian Haas for the first question, Geronimo Gerrit for the second one, and Rodolfo, assuming it was your question, the last one. I think now we'll leave the chat room open for a couple of minutes while we're standing here. Feel free to comment, any feedback, anything you would like to discuss. It's not so much discussion forum because we're 2 people talking together, but feel free to write in the chat now for the last minutes. Rodolfo is asking, do you use other tools to monitor errors?
Yeah, so we have a few tools. First is distributed tracing is more a tool for long term. So if you have some bad trends, then you are kind of need to see what's going on. This is
just to continue.
Yeah, so X-ray, this is distributed tracing is for long term. Logging for short term, so if something happens. Our error tool is OpsGenie. So this is tool was bought by Squared by Atlassian. So it's their tool right now. So it's just like alerts. So if you have too many errors of your CPU utilization, we have like different setup of different applications, and you just receive an alert and you see, okay, so this is happening here in our app. We have priorities, so P1, P2, P3, P4, P5. Depending on the priority itself, either you wake up or just continue to sleep, and it will be being ignored. That's also, and Grafana, if you, for example, at work and you have your screen and monitoring just the usual trends of your application, we have just dashboard of the whole service has dashboard, and like specific dashboards for the let's say dashboard has for domain, and then specific dashboards for different services like that work on this domain.
Cool. Christian Hans is saying, thank you, Alexander.
Thank you.
Thanks. It's very, what's the right word? Courageous and sportive of you to try this out with us. I think we'll leave it at that. We'll probably have the camera open maybe for another minute or two, and feel free to try and do something in the chat. Otherwise, yes, thank you so much. Good. Thanks everyone for coming. Thanks for joining. Give us some feedback in the comments or review the meetup, comments of the meetup or in the chat, so we can know if you liked it. Rodolfo Cavallo says, thank you all. I meant to put on the camera already 5 minutes ago when we started the questions, but I realized that we didn't, so we have yet some stuff to learn. Yeah, and really, without speculation, because I've seen different stuff in the news, I still hope that this pandemic is over soon and that we can get back to a regular schedule, and barring that, depending on if we get speakers to join here or not, if we don't get some local speakers, we might do a virtual meetup next month if we're not out of these event restrictions then and stuff is going better. But just stay tuned. Just for now, all the physical meetups are cancelled. Will not happen in person. Okay. So no more questions. Really appreciate everyone that was joining. I saw we had now we're sort of 7 people in the chat supposedly. Now something happened here, but I think that's our cue. Thanks everyone for joining. Thanks for coming, and stay healthy. Take care.